Keeping the party going here. Thank you so much to the Stash team. Riemann Computing, we have Andrew Kamal on the line. Please come on in and tell us a little bit about what you're building here.
Yes, let me share my screen real quick.
Absolutely.
Chrome tab. So Riemann Computing, formerly known as Stark Drones, builds a wide variety of different technologies centered around disrupting telecom and infrastructure as industries. One of those technologies is an internet balloon system, and we found a way to do internet balloons direct from balloon to terminal gateway for as little as $17,500 per single CubeSat launch. This is a little bit about the network architecture diagram, which you can feel free to look at the pitch page. But the core technology is centered around data compression and its own signal compute module. Our data compression is 20x cheaper than the #1 player in the world, according to the data sources that we have so far. The #1 player in the world, according to Cable.co and Talkhome and various sources, is Israel, and that's supposedly, I think, the Israeli Defense Forces. We are 20x better in terms of cost optimization. Our goal is to be able to launch pilots in different cities. So we're currently pending FCC approval. This is a highly regulated industry. And we have basically each pilot that we do requires a telco license, it requires land, it requires infrastructure, legal costs, additive manufacturing. And in terms of why we want to do this, every single CubeSat that's a $17,500 launch, we're trying to aim for 100 megabyte uptime, 25 megabyte downtime, and provide internet to 7,500 people per CubeSat at 18-kilometer radius. And then we have a cost per satellite comparison because we utilize data compression and miniaturized CubeSats, as well as like a helicite or aerostat to carry the balloons. Our costs are actually much lower compared to the competitors. This says 10 megabytes, but Zen 2 is being designed for actually 25 megabytes, and the goal is to have $5 a month internet plans. And that's with profit margin. Other technologies we're trying to do is telemetry plus power. So we have our own compressed air energy storage solution, as well as a water harvesting solution that's in the works. And we want to provide this technology in different third world countries. We have various different patents. Right now, it's actually currently now becoming 8 patents and multiple trademarks. One of them is provisional. The rest are non-provisional. And one of them was cited by Red Hat, which is a subsidiary of IBM. And we're basically trying to build an integrated solution of these technologies and do pilots from city to city if licensing would allow. The main goal outside the US of different third world countries, especially in places like Ethiopia or places where resources are going to be very scarce, because scarcity in resources actually is one of the biggest causes in the world of genocide and war. And we believe that this could actually solve this or be an integrated solution for a lot of like Africa, Southeast Asia's problem, as well as even helping here in first world country where cabling for internet, for example, is sort of bought. The rights for your internet is bought in terms of you having a subdivision or a builder having a subdivision, someone buys the cabling rights. Since we do internet balloon and we don't require cabling or fiber optics or any of that, we have a way to sort of bypass that. And part of the cost is the legal logistics with licensing to become an ISP. And then obviously we want to, for the compressed air energy storage, which is another one of our integrated solutions of trying to provide water, power, and electricity and connectivity, we want to actually build a generator based off of that. And we also want to build solar arrays that provide water harvesting that utilizes for reverse HVAC the offset heat from the generators. So these are sort of designs of what we see happening in the future. And there are also budgets. There are various different streams that we'd have. So obviously city to city CubeSat, we're business to business. We're also an infrastructure service provider. And that's a little bit about the technologies that Starcom Global actually works on.
That's fantastic. Thank you so much for that presentation, Andrew. And obviously, you have to be quite bright to be doing what you're doing. I think one of the many skills you have is in quantum engineering. So if that was over the heads of anybody else here, do not feel alone. We're going to do a deep dive into some of the things that you covered here. But before we get into the underlying technology and some of the pilots that you've already run, can you tell us a little bit about the rest of your team as well? I know Trevor Miller is your software architect and Joe Mancy is your project engineer. Can you talk about some of the rest of the folks helping bring these projects into fruition? Let's allow that one more moment. Oh, thanks for bearing with me for my panelists, my attendees here.
About that, can you hear me?
Hey, we can, no problem at all. No, I was actually just can you hear me as well, Andrew, before I dig in?
Yeah, I can hear you. I'm gonna answer the question in regards to team. Trevor Miller worked on a platform called Bitbazis, which is kind of a subsidiary slash partner with Raymond Computing. Bitbazis is like a peer-to-peer blockchain platform that's centered around digital identity and multi-chain hosting on the blockchain. But basically, the software that he's building is going to be the architecture for people logging into like their ISP plans, for people being able to have user accounts and authentication, and it's very cool. Other people like Joe Manzi. So Joe is basically helping with optimization for project costs. He's a very good engineer. He knows how to minimize costs for a lot of these pilots, which is very important for these types of launches. And that's actually his specialty is cost optimization as a project engineer. So he's sort of like kind of in a way almost like my right hand man when it comes to a lot of the launches and things like that. And then we have people in media. We have advisors that are trying to bring this technology to different countries, especially in the third world. And that sort of makes our core team, besides a few business dev guys on the side.
Oh, fantastic. Thanks for that. That's exactly what I was getting to. And there was and you actually mentioned being licensed as an ISP already. You mean as an internet service provider. Are you going through the licensing process or have you
We're
already
going through
completed
the
that
licensing
process?
process. We're not licensed already. Just a quick clarification. We're going through the process, so there's a lot of due diligence involved in terms of like lawyering and stuff like that. I'm mostly pro se, but part of it is trying to get a DNIC number, a ROA number, Section 214 authorization. Then you're also talking about experimental authority from the FCC. Then you're talking about working with city councils. We're already working with having applications already pending with the FCC, and we're already talking to different city councils. One of them is Harbor Beach, which we did a telemetry test launch before, and we sort of have to go from low elevation to higher elevation. So it's sort of a lot of bureaucracy, but that's also given that this industry is highly monopolized. So you have Intelsat, Starlink, Comcast, T-Mobile. Obviously, they don't want to make it easier for you to bypass traditional centralized ways of, hey, I bought the rights to cabling in your subdivision. You're stuck with our internet plan, and we could just throttle the speeds and prices. So
No, yeah, there's definitely some incumbents that I imagine are going to be interested in either working really closely with you slash acquiring you or trying to keep you from getting to that position. No, that's really thank you so much for doing a kind of a clarification on the ISP component, but that is fantastic. Let's talk a little bit about because the technology is so exciting here. Let's talk a little bit about your intellectual property strategy here. So I see a couple of exciting pieces of traction already. Your compression algorithm is patented. Can you talk a little bit, I guess, about some of the protections you've put in place for the underlying technology, including that compression algorithm?
yeah, I mean, with protection, there's still infringement that goes around every once in a while. I mean, we even have a case with potential infringers right now, so patent is not the last step. But we cross-patented in the US, and we recently heard from our examiner. We're still waiting on a confirmation from the Chinese patent office that it also been approved for grant in China. It's a two-way system. So basically, data compression is used to compress the network packets for signal latency, and then the other part is our signal compute, which is why the compute module was patented. So the compute module offers basically like inter-peered connectivity from CubeSat to gateway. and we're compressing the actual network packets. So that's sort of how it's built as a system. There's another thing we're working on currently that has not been patented yet. It's sort of a trade secret, but we also have our own composite to try making even our own helium balloons to hold helium for prolonged time periods. There's already a lot of industry players like aerostats by Helikite and stuff like that that does that. We found out the cost of those types of specialized balloons is too costly, so we're like, why don't we just make one of our own? So very interesting stuff.
Super interesting. Yeah, not just the compression algo, but also the compute module. And that sounds good. Almost sounds like building in a potentially material science play here as well with the helium balloons. That's fantastic. As a reminder, we're about halfway through our time here on the entire program. Please continue to ask your questions through the Q&A feature built into Zoom. We want to get to as many of those as possible. And we are on the line speaking with the team with Raymond Computing, formerly Stark Drones. I'm adding a link to that into the chat feature as well in the Zoom here. For those who are not looking at the screen themselves, you can go to netcapital.com/companies/Stark Drones. Again, it is Raymond Computing, formerly Stark Drones. But you go to netcapital.com/companies/Stark Drones or search Stark Drones on the Netcapital platform where you can learn more and potentially invest. A couple more, one more quick question before we wrap up here, because this is actually a really exciting piece of traction as well. For folks who want to understand where you are in the process of being able to deploy these balloons, you already had a city-approved telemetry test launch for the internet balloon system. Can you talk a little bit about some of the traction involved and actually launch?
Yeah, we were able to directly have a CubeSat that was live feeding. It was at the bare minimal elevation, which is past the 400-foot mark, so 500-foot elevation. We have a 1250-foot elevation launch that's pending approval by the city of Harbor Beach. We don't know if it will be approved or not. Obviously, there's a lot of bureaucracy with that process. City council is actually meeting on the 19th to discuss that. The goal is to get it all the way up to launch by launch until we get 5,000-foot elevation approval. And then if all the tests are successful, obviously we want to now pitch to Michigan Public Works as being, and this is assuming FCC licenses are underway, of being a telemetry provider and actually having fully tethered permanent balloons in the that are offering people connectivity. So
I think for the developed nation, the exciting prospect is that you can like kind of you remove some of your dependence on your current internet service provider. And a lot of us have fiber optics. A lot of us have just one option. Some places have even fewer than that. There are still parts of the United States that don't have true access to high-speed internet, which is a shame. Can you talk a little bit about the humanitarian impact, though? You did mention how much strife results from not having access to resources. There's lots of parts of the world that don't have access to high speed or even just access to internet in general. Can you talk a little bit about what your vision for access to the internet as it sounds like maybe a basic human right? Or you can talk just a little bit about the humanitarian impact of being able to access this
yeah,
information through.
um, yeah. There's two things I wanted to quickly mention. ISP plans are currently just the present. Right now, the goal is eventually to create codecs that would be like ISO standardized, which is a whole bureaucratic and legal process that we're hoping eventually to get funding for. But in terms of what our end goal, like phase one, is internet. There's a lot of digital literacy gaps. There's also the idea of being able to outsource people. So we believe that connectivity could offer actual double-digit economic growth for a lot of tier two, tier three countries. And then the other thing is water and power, especially when you talk about like the scarcity of resources in relation to like plantation and various things like that. That is one of the things that sort of orchestrates like a lot of these genocides. Like Ethiopia, there's about 10 to 12 million people that are expected to die off of starvation and resources getting shut down. We're building a way where people could have a solution for what they need in terms of power, water, connectivity, and all the basic needs that's centered around infrastructure that's still cost effective, that still could give us decent profit margins, and could still end up being substantially cheaper than a lot of the mainstream infrastructure providers. And hopefully that would fix a lot of those problems and those issues obviously less censorship when you're dealing with a way to have WLAN, TCP/IP connectivity, and freedom of information, freedom of truth, and all that are other aspects of it. So definitely a humanitarian component. We actually have even our own nonprofit sub entity that wants to eventually get into that niche of being able to offset and provide some of these even in the future for free if they're subsidized by grants and things like potentially maybe proposing World Bank grants and all that.
That's amazing. I really wanted to just share a little bit about that vision of it because this is bigger than me having lower latency while playing Fortnite. This actually has a pretty potentially a pretty big global impact. So I think that's incredible, Andrew. I have to sneak in one more question that came in. Sorry, before we go on to our next presentation. Does this tie in at all, or do you imagine this could tie in at all to the infrastructure bills? We're having a lot of conversation now at the federal level around supporting building on infrastructure. And I do think high-speed internet and internet in general connects in there. Are there any relationships there that you want to tie into some of the kind of pushes towards infrastructure, at least in the United States?
Yeah, I mean, a lot of the current regulations are centered around outdated infrastructure or the outdated grid, especially when you're talking about these balloons, right? These balloons could be tethered very easily to high-rise commercial buildings and be way under the elevation zone for flights and stuff like that. But because the current infrastructure bills that are in place, a lot of this is very difficult to do, way too much bureaucracy. And a lot of people have had bills centered around updating our grid from power walls to actual telemetry mechanisms that could be better, especially when you're talking about, let's say this is approved by the FCC, then you have to go on the state level, then the city level, and then you have to do it state by state by state traditionally. And there are ways where bureaucracy could be greatly diminished if some bills that would allow for more open infrastructure, especially when you're talking about direct US exporters and importers, made in the USA and all that as being the core. I think that's very important, even though some of our electronics are made overseas. The team that builds this in the US if we're gonna do like US launches per se. So it's definitely very important to have bills in Congress that pass that allow for things like these to be built without over regulation and over bureaucracy that's traditionally made for monopolization of these industries that prevent the small players and the innovators.
Wow. Well, thank you so much for the work that you're doing, Andrew. I appreciate you coming on and sharing your vision for Raymond Computing. Again, I did add a link to that. You're going to search Stark Drones. This is Raymond Computing, formerly known as Stark Drones, on Netcapital.